2 times 2. Okay, so, but what we're going to deal with today are some rules or shortcuts, if you will, to exponent rules, and sometimes they're going to be with a variable in them where you just have to simplify. So x cubed, I'm going to write this out the long way. X cubed would mean x times x times x. And then what would x squared mean? X times x. So if I wanted to write that as one exponent, that would be x to the 5th power. Okay. So the shortcut is when you have the same bases. So if you have x to the m and n are going to be numbers, the shortcut is you can add those together. Okay. We're going to start dealing with some negative exponents. And a little later down here, I'll talk about what a negative exponent means. But if I used that same rule for this one and I added those exponents together, how could I write 2 to the 5th times 2 to the negative 3rd? Let's add those exponents. 2 squared. Okay. Now let's talk about when you raise something that has an exponent to another exponent. So I'm going to show what this means. 5 cubed means 5 times 5 times 5, correct? And to square it means I'm going to multiply that by itself again. So inside I have my 5 cubed, and here I have a product of 2 of those things. That's the squared part. That's 5 to what power? 5 to the 6th. So if you have an exponent raised to another exponent, the rule is that you multiply those exponents together. So how would I write y to the 4th to the 3rd then? So my rule is, what happened here is I could do a shortcut by multiplying those together. Okay, I wrote it out the long way, but I got that it was 5 to the 6th. So how could I write y to the 4th, the 3rd? Y to the 12th. Okay. Good. Okay. What about if we have a parentheses? So I have a parentheses around that a and b, and then I raise that to the n. So no matter what, and it could be 2 things, it could be 3 things, it could be more than that. If you have a parentheses and you raise it to an exponent, you need to raise all of the things that are multiplied in that parentheses to the exponent. So a to the n and b to the n. Okay? All right. So in other words, 5x parentheses squared, and this is a really common mistake. Students write 5x squared. But it's not. It's 5 squared times x squared. What is 5 squared? 25. So if I had this whole parentheses, x times y, so there's a parentheses around it, and raise it to the 6th, I would need to raise x to the 6th and y to the 6th. Okay. Quotient. Quotient means what happens when we divide things with exponents. Okay, and I'll show you this the long way again so you're understanding what's happening. 4 to the 7th. Let's multiply out or write out 4 times 4. Let's write that out 7 times. 1, 2, 3, 4, 5. And on the denominator, 4 cubed. Okay. So you can see up here that the rule is that you subtract the exponents, but let me explain why. When we have a number divided by itself, isn't that just 1? So I can do that with 3 sets of the 4s. Then how many are left? 4. And so what you're doing is you're saying, hey, I can take off the bottom number of those exponents, so you're left with a to the m minus n. You subtract them. Okay. So let's use our subtraction rule, and then later I'm going to talk about a negative exponent, but I'm going to show you what it means in a second. If I use this rule, and you do 3 minus 13, don't you get a negative number? Yeah, what is it? Negative 10. So this is x to the negative 10th. Let me show you what's really happening here. If I have x times x times x on the top, wow, 13 x's, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yikes. Okay. How many cancel? 3. But do you see where they are? Are they on the top or on the bottom? They're on the bottom. So the way I would write this is 1 over x to the 10th. So I'm going to just point that out right there, that those two things mean the same exact thing. Okay? And we'll get to that a little later on. Okay, kind of similar to before, even if you have a fraction and you raise it to the exponent, you have to raise both the top and the bottom to that exponent. So this is the same as that. So let's do 3 over 5 squared means 3 squared over 5 squared. And then if you want, you can write those out. What is 3 squared? 3 times 3 is 9 over 25. So x over 2 to the third would be x to the third over 2 to the third. I can't simplify x to the third, but could you simplify 2 to the third? 2 times 2 times 2. 8. So that's the same as x to the third over 8. Okay, this is kind of crazy because people want to say that it's 0. Anything to the 0 power is actually the number 1. And here's the reason why. Do you remember how I told you exponents are repeated multiplication? So what an exponent represents then is the identity in multiplication, meaning what number would you multiply by that wouldn't change the number? That would change it. 1. So when I have a to the 0 equals 1, it's because I want to represent 0 multiplication, but 0 multiplication or keeping things the same is actually multiplying by the number 1. So if I had 2 to the 0, that's just, no, 1. 2 to the 0 is just 1. 2 to the first is 2. Okay, but anything to the 0 power is 1. What if I have, now hold on a second. This has this raised to the 0, but what's out in front of it? 4x plus 1 raised to 0. There's a 2 out in front. All right, so the thing I highlighted in pink, that is 1. But there's a 2 out in front of it, so it means 2 times 1, which is 2. Okay, the big thing about negative exponents is that they do not represent negative numbers. So I'm going to have you put that there. Negative exponents are not equal to, so you put a equal with a slash through it, negative numbers. So just be real careful with that. What a negative exponent means is a reciprocal kind of thing where you're moving things around from the top to the bottom of a fraction. So a to the negative n means 1 over a to the n. All right, so how would I write 2 to the negative 1? I'd write it as 1 over 2 to the first. And 1 over 2 to the first is just 1 over 2. What if you then have not just a single thing, but what if you have a fraction raised to the negative exponent? Well, then you have to take or flip that fraction around, take the reciprocal. So a over b to the negative n, flip it around, is the same as b over a to the positive n. So let's do that with a real one. X over 4 to the negative second. We're going to flip the fraction around. What's on the top now? 4 over x, and then to the second power. That's how you rewrite a negative exponent as a positive exponent. If I wanted to keep going and use my rules from before, this would be 4 squared over x squared. Or 16 over x squared. Okay. Just be really careful that if there is a negative exponent on only one of the things, that's the only thing you move. So here's my example. On something like this, and they're all negative, you're going to move everything that's on the top to the bottom of the fraction, and if it's on the bottom, you move it to the top. So that a to the negative n, it moves down here. That b to the negative m moves down here, and c to the negative p moves up here. Okay, but what about this one? That's a negative exponent. The y to the 8th is not. So if you have a mixture of them, the only things you move are the negative exponents. So this x to the negative 4th is going to move to the bottom. Y to the 8th is not going to move because its exponent is already positive. This would give you 1 over x to the 4th, y to the 8th.